Hello and welcome back to my channel once again. This is your man Alam, and today we are continuing with Plane Geometry 2. If you have not watched my previous video on plane geometry, you'll quickly do that on the link below. The link will be kept in the description. Just go and watch it. Now, when we talk about plane geometry 1, it both dealing with angles and then parallel properties. In plane geometry 2, we are emphasizing on angles forming in a circle. That is why we have the topic as Circle Theorem. So without much ado, we continue from this Theorem 5, which states that the angle between a tangent and a chord is equal to the angles in the alternate segment. Let's take a circle for instance. Then we draw a tangent. A tangent is any line that is drawn to the circle. So this line is what we call a tangent. Now, when I have a chord to this tangent, this is the chord to the tangent, it is equal to 22 degrees. Now, this 22 degrees, we are saying that it is equal to the angle in the alternate segment. So it means that this is also at 22 degrees. Let's take another example. Another tangent, a chord, and the alternate segment will also be the same 57 degrees. Furthermore, this is also equal to 57 degrees. Now, another one. So if the chord here is 18, then the alternate segment will also be 18 as indicated. Now, highlighting it more, we are saying that the tangent and the chord highlighted by the red line is equal to the alternate segment highlighted by the blue line. So looking at the movement very well, so the tangent is here and the chord drawn to the circle is equal to the alternate segment. So 20 degrees here is equal to 20 degrees here. Likewise, this one. So this is the first chord withdrawn from the tangent, which means that the blue highlight is also 57 degrees, which is also equal to this, as it is also in the same alternate segment. So this side is also 57 degrees. Now, when we highlight the third one too, it's the same thing, 18 and 18. So this is the chord and this is the tangent, alternate segment, and this another alternate segment, which means that the angle formed here and the angle formed here are all equal to the angle formed by the tangent and then the chord. Alright, so let's do a workout. So this is an example. Which angle do you think is A and which one do you think is B? Alright, we are working out these missing angles. Now you can foresee how you can work for A and you can get B within no time because of the theorem we have already looked at. Which one is the 79 as I asked earlier on? Now highlighting it with the red line, we got the angle formed between the tangent and the chord to be 79 degrees. Now we want to get the alternate segment, which is highlighted by the blue line. So definitely you will know that A is also equal to what? 79 degrees. Alright, then if A is 79 degrees, what is B? We know here to be 30 degrees, we know here now to be 79 degrees. What is B? We can apply the triangular properties of angles. We know that angles in a triangle sums up to 180 degrees. There is a formula in solving it, that is to find the number of or the sum of angles in a polygon, regular polygon, whether a quadrilateral or any other regular polygon. So it's n minus 2 multiplied by 180, and where n is the number of sides, so triangle has 3 sides. So when I pick 3 minus 2, I get 1. 1 times 180 is 180. That's why the sum of all the angles inside a triangle is equal to 180 degrees. Now to get b, I will take b plus 79 plus 30 degrees, and this will give me 180 degrees. Now you group like terms. Maintaining b, we subtract 30 plus 79 from 180, and that's going to give us 71 degrees as the b. You can pause the video and sit down and look through it and work it out by yourself to get more understanding. Alright, let's proceed. Now, this another example for us to get it more. The angle between a tangent and a chord is equal to the angle in the alternate segment. So the angle TPQ, that is, let's say this angle here, that is x, is equal to the angle PRQ, which is also highlighted by the blue line. So here, if here's x, is also x, as we did earlier. So here's y, this will also be what? Y, as we have seen. Now, we want to prove this theorem to see why are we saying so. But to prove that, we need to draw a tangent, a chord, and an angle in the alternate segment. So we draw a circle first, then we get a tangent. So this is a tangent, we get a chord, and we get the alternate segment. Now, to continue, we know this is a chord which is touching the tangent, and the alternate segment is highlighted by the blue line. Now, further elaboration, we need to use the center of the circle and an associated triangle for this proof. So we need to locate the center of this circle we have drawn. So let's say this is the center. Now, after getting this center, we can draw two radii as shown. We know the radius here and the radius here are all equal. Therefore, the triangle formed is an isosceles triangle. An isosceles triangle states that the base angle are what? Equal, because this line and this line are all equal. They are all radius. And then if we call the original angle as x, the angle that is tangential to the chord, this angle, if you call it as x, that is what I mean, then we can get this small angle, because any line drawn from the center to a tangent forms a right angle, that is 90 degrees. So if this is 90 degrees and I know this small brace will be x, then the interior of this triangle will be 90 minus x. With 90 minus x. If there's 90 minus x, this angle over here should also be what? 90 minus x, because it is an isosceles triangle and the base angles are equal. Okay. Notwithstanding, we got this side and we got the other angle. We can solve for the third angle in the triangle by using the triangular property. So we sum everything inside here, that should give me 180 degrees. And when we solve it, we realize that 90 plus 90 was taking it from 180 is 0, then leaving 2x. So this angle is 2x. But in my previous video, which I will encourage that you go back and watch it, just the link is in the description below. Just go and cross check it. We talked about another property which states that this angle from the 2x here is twice the angle that is subtended at the circle. So it means that if here is 2x, the angle formed here will also be x. The angle here is 2x, yes, we were 2x. Now, well proved. This angle is x, and we have proved that it's also x. So it means that we have proved our alternate segment theorem very well. You can sit down and imagine it and go through it again. So this angle here is equal to the angle here as we have proved it. So first of all, we know that this is 90 degree. If this is 90 degree and the initial angle we say is x, the inside of this triangle should be 90 minus x. This should be 90 minus x. We sum it up and equate it to 180, and I get here to be 2x. But the angle formed here is twice the angle subtended at the circumference of the circle. Therefore, here is x, and that is 2x. Now we well prove it that x is equal to x. Alright, let's take an example. Work out angles A, B, and C and justify your answer. When you get A, you have to give reason, because here we don't need much working. We use the theorems to get the lettered angle. So you have to give a reason to why you are saying that A is equal to that, and B is equal to that, and C is equal to that. That's why we say give a reason to your answer, justify it, and you are good to go. Now, this is a very nice question. We are looking for A, B, and C. Now, if this angle to the tangent and this chord is 55 degrees, what is A, what is B, and what is C? Which one can we relate it to? Now, angle A, we are finding this is a tangent to the chord, and the angle formed there is 55. You realize that the alternate segment is formed at A. Therefore, A is equal to 55 degrees. Alright? A is equal to 55 degrees. Now, we want to get B. But to get B is very simple. We know that this line here is a diameter because it's passing through the center. And this line is a diameter. The angle subtended to the circumference from the diameter is 90 degrees. So this angle is 90 degrees. So if there's 90 degrees and I know this way to be 55 degrees, I can easily find B by summing it up and equating it to what? 180 degrees. And when we do that, we realize that B will be equal to 90 plus 55. Take from 180, and that will give me 35 degrees as the angle B. So B is 35. Now we're going to get C. C is also a tangent to a chord. So the angle formed there is relating to the 13 over there. So if this is the angle, C, the tangent, and the chord, the alternate segment is 13 degrees. Therefore, C is equal to 13 degrees. Alternate segment theorem. Now, continuation, still on the theorem 5. Which angle will be 72 degrees and which one will be what? 59 degrees. You can pause the video and look at it. But don't forget to subscribe to the channel. Hit the notification button so that you'll not be left out when I release any new video. Alright. So we want to look for which angles, is it A, B, C, or D? That is 72 degrees. And which of them is what? 59 degrees. So with something like this, we need to apply the bow tie to help us. You know that this is like a bow tie, highlighted by the red line. It's like a bow tie. We want to use that theorem, which says that this angle A is equal to the angle C. The angle formed here is also equal to the angle formed over there. The angle B is equal to the angle D. So let's continue. Now, still applying the theorem, this is a tangent to this chord, and the angle formed there is 72 degrees. What is the alternate segment? The alternate segment is formed at A. The alternate segment is formed at A. Therefore, angle A is equal to 72 degree. So if A is equal to 72 degree, then C will also equal to what? 72 degree. Just simple as that. Now, when we got it, then D is also answered using the bow tie theorem again. B here is equal to D. But we also know this another tangent and to the chord, which is 59 degree. Now with this, we get the alternate segment to be D. So if I know D to be 59, then B is also what? 59. Alright, so they are all 59, 59, and the solution is being solved. Take your time and go through it. Pause the video and solve it by yourself and see whether you can master it. Alright, the next theorem, theorem 6, is saying that the opposite angles in a cyclic quadrilateral are supplementary. Thus, they sum up to 180 degrees. That's the meaning of supplementary. When you say the angles are supplementary, it means supplementary angles, we know they sum up to 180 degrees. Now, opposite angles in a cyclic quadrilateral. So this is a circle and a quadrilateral form inside it. A quadrilateral is a four-sided plane figure formed inside a circle. We are saying that the opposite angles sums up to 180 degrees. That is, when I sum this angle and the angle down here, it should give me 180 degrees. The angle Y should give me 180 degrees. And this angle. That's why we have to take Y from 180 degrees. Alright? So if here is Y, this angle will be 180 minus Y, because they should sum up to 180 degrees. Likewise, if here is X, then here should be 180 minus X. Well said. Now we pick a work example. Just pause the video and try going through it. We said that Y plus 100 should give me 180. So if 100 is given here, then Y definitely will be what? 80 degrees. If here is 95, we can easily find the X to be what? 85 degrees. Now, angle X and 95 degree here sums up to 180 degrees. That is, the opposite angles in the cyclic quadrilateral are supplementary. That is our justification. That is our reason. So when you sum them up, we know X is equal to 85. That is, when I pick X plus 95, it should give me 180. Then you subtract 95 from both sides. Then X is equal to 180 minus 95, which is 85 degrees. So the value of X is 85 degrees. Now, also the Y and the 100 will also sum up to 180. So Y is equal to 180 minus 100, and Y is equal to 80 degrees. Simple as that. Now the theorem 7 says that the angles subtended by equal chord at the center of a circle are equal. When we talk about equal chord, it means this is a chord and this is another chord, and they are equal, indicating by the red lines. It means this line is equal to this line, and this line are forming at the center. This is center, so over there, and this one. So the angles formed here, angle X is equal to the angle formed over there, because their chords are all equal. So X is equal to X over here. Now, without much ado, let's take an example. We are looking for the value of X and Y. Now that we know this angle to be 46 degrees, we can find X, because this is an isosceles triangle. Isosceles triangle, the base angles are equal, because this is a radius and this is another radius. So if this is a radius and this is a radius, it means that this line is equal to this line, and the base angles must also be equal. So if here is 46, this angle must also be what? 46. So I pick 46 plus 46. plus x, that should give me 180 degrees. In short, the triangle OAB is an isosceles triangle. Then this angle, like I said, and this angle are all equal. Angle ABO and OAB are all equal, which is 46 degrees. Therefore, I can find x by equating AOB, which is x. AOB is x, that's its angle. AOB. Where you curve is where the angle is formed. AOB. So it means the angle is formed at where you are turning. Okay. Which is equal to 180 minus 2 times ABO. ABO. That is 46 degrees. So we know that this is twice. This and this is twice the same figure. So 2 times 46 is the same as 46 plus 46. When you take it, it becomes 92 degrees. 92 degrees from 180 degrees is 88 degrees. Therefore, the x is 88 degrees. Now, if x is 88 degrees, then y also 88 degrees. Why? The angles subtended by equal chords at the center of a circle are equal. This angle and this angles are equal. Therefore, y is also what? 88 degrees. Well said. Let's take the 8th theorem. And this theorem says that the angles subtended by equal chords at the circumference of a circle are equal. So this is a chord and this chord are equal. Now, when these chords subtended at the circumference, that's this, they are equal, it means that the angles formed are also equal. The angle formed are also equal. So this angle and the angle formed from the same equal chord. This chord and this chord are equal. So therefore, this angle is equal to the other angle. Well said. Now, we pick an example. We state that the angle x is what we are looking for. And the angle formed here is also what we are looking for. That is CFD. CFD, that's angle x. And then FCD, that is this angle formed over here. We are looking for them. But we know this angle to be 30 degrees. When we know that to be 30 degrees, we know this angle is equal to this. Therefore, x is equal to what? 30 degrees. If x is equal to 30 degrees, then I can find this angle by applying the triangular properties. So when you sum x plus 100 and this angle, is to give me 180 degrees. Therefore, I take 30 plus 100 from 180, and that is going to give me 50. So therefore, the angle formed here is 50 degrees. That is FCD is 50 degrees. That is well done. Let's take the final question. That's a preliminary question. So we find the value of y in the figure drawn below. So just with the last property we looked at in the other video, we know that this angle here, this 100 degree here, is twice the angle formed at ABD. Likewise, ACD is also half of the angle formed here. But we can easily get y by applying a lot of theorems. Now, angle CAB, that's this angle formed here, and this angle, they are equal. That's the property 2 we looked at in the other video. We said that this angle here is equal to the angle formed over there. Bow tie property. So these angles are equal. So it means that if here is 40, here must also be what? 40. Now, we continue. The angle AOB, AOB, AOB is twice what? ABD, which means that angle ABD is equal to half of AOB. That's why we have angle ABD to be equal to half of AOB. Now, this is further equal to, we know this angle is AOB is 100 degrees, so half of 100 degrees is 50 degrees. Now I know this angle to be 50 degrees. I know this small one to also be 40 degrees. So when we sum them up, that's 40 plus 50, that'll give you 90. You take it from 180 degrees, and you're going to get your y. So at 180 minus the sum of these two angles, that will give me y to be 90 degrees. So therefore the value of y is 90 degrees. Thank you for watching. Don't forget to subscribe to the channel, and more to the point, hit the notification button so you'll not be left out. Share to bless a friend. You can support the channel too to move on well. Thank you, and may God bless you.